Hi everyone. So as we move towards working more with the Pythagorean theorem and radicals, I want to review some things that you're going to see that you actually know how to do, but they look funny when we're working with radicals. Our first example is when we have a radical that's being squared. Now, we've talked about the fact that they are inverse operations of each other, that the square root and the square undo each other. So this kind of cancels that out. The reason that is because when we square something, we know we multiply it by itself. Okay, so we would multiply root 3 times root 3, which would actually give me root 9, which then would give me the number 3. So if you can think about that, that is a very helpful thing to just kind of think about, that when I square a square root, I'm going to be left with what's the number under the square. All right, now it gets a little trickier if I have a number in front of the radical. Make sure you remember that these two things are being multiplied. So this means 3 times the square root of 11 squared. So I have to be really careful because that means that I have 3 squared times root 11 squared. Okay? So 3 squared, so I have to make sure that I square both the 3 and the 11. So 3 squared is 9, and then root 11 squared is 11. So this would give me 99. All right. So I want you guys to try that. I want you to try 3 through 6, okay? 3 through 6. And so press pause, try them, and I'll give you the answers, okay? All right, so root 24, you hopefully broke that down into the square root of 4 times the square root of 6, which would be 2 rad 6. Root 5 squared would just be 5. 2 root 7 squared would be 4 times 7, which is 28. And 7 root 2 squared would be 49 times 2, which is 98. All right, now let's look at it a little bit harder. We got to remember that when we square quantities, that everything within that quantity, everything within those parentheses has to be squared. So in example number 7, I have to square the 2 and the x. So this would be 4x squared. In example number 9, I have to square both the top and the bottom of the fraction. So root 2 squared would be 2, and then 2 squared would be 4. Then I simplify to 1/2. So I'm going to have you try 8, 10, and 11. Okay, so take a pause and try it. All right, so you should have squared the whole quantity, so 9n squared. You should have squared the whole quantity on number 10, so n squared over 3. And on this one, we had to square the fraction and the root. So that would have given us 4 over 9 times 6. Then I would have simplified because I can simplify by 3. So 3 goes into 6 twice, 3 goes into 9 3 times, and so I would have gotten 8/3. All right, now let's look at a different operation with radicals. We're going to look at addition of radicals. Addition of radicals is legitimately, it's like the same thing as combining like terms. You can't change the radical. You can't square it. You are just adding it. So root 2 plus root 2 would be the same thing you'd do if this was x plus x. You'd say that was 2x, so this would be 2 times root 2. Root 5 plus root 5 would give me 2 root 5. It means you're doubling it, right? Like you've got 2 of them. And then root 7 plus root 7 would give me 2 root 7. Now, you could get something like this. 3 root 5 plus 2 root 5. And again, it would just be like 3x plus 2x. So 5x, or 5 root 5 in this case, okay? All right. So let's look at the last thing. Last year in algebra, you learned about multiplying binomials. Now, we've talked about this a lot this year as well, and there is a very common mistake that we are not going to make, right? We're not going to distribute that 2 over that polynomial. We're going to remember that x plus 2 quantity squared, so in parentheses squared, means x plus 2 times x plus 2. Now, a lot of you have used the term FOIL to multiply these, and yes, you absolutely can. It's going to give you x squared plus 2x plus 2x plus 4, and so x squared plus 4x plus 4. Okay, so I want you to do 16 and 17 and 18 and bring them to class tomorrow. And if you're really interested on learning a quick way to do this in your head, come see me and I'll show you something really cool about multiplying binomials that are binomials that are quantity squared. I have a trick for you. Okay? All right, see you tomorrow.